Good day, everyone. Before we discuss our second topic, may I introduce to you the reporters, Tanya Bia Serrano, Archie Gonzalez, Richelle Reyes, Fernand Luis Domingo, Angelica Magno, and Russell Edrada.
Good day, everyone. Today, we're going to talk about hydrogen power plants. Let us discuss what is a hydrogen power plant. A hydrogen power plant is a concept designed for a new widespread source of electricity. Essentially, it is a facility which uses hydrogen to produce electrical energy. So sa pag-produce ng electrical energy, kinakailangan gumamit ng pure hydrogen, meaning it doesn't form any other compound elements. Large tanks of liquid hydrogen will fit into thousands of hydrogen fuel cells. These fuel cells are solid structures containing an electrolyte fluid and two terminals, much like batteries. Yung primary component ng isang hydrogen power plant consists of hydrogen fuel cells, which function similar to batteries. The reactants flow into the cells, in this case hydrogen and oxygen. They intermingle with electrolyte to produce an electrical charge and water as a byproduct. The water flows out another port while the electricity is siphoned off the terminals and held in a gigantic multi-ton batteries. The electricity resides in the batteries until it is needed, in which case it is sent out through the local power grid just like any other type of power plant. Next is the battery parts and functions. First one is electrolytes. It is a chemical compound that conducts electricity by changing into ions when melted or dissolved into a solution. It can be a liquid or paste-like substance, like ammonium chloride, zinc chloride, potassium hydroxide, lithium tin phosphorus sulfide, and sulfuric acid.
Anode. So what is anode? It is the negative or reducing electrode that releases electrons to the external circuit and oxidizes during the electrochemical reaction. For example, example of it is zinc, metallic lithium, and lead. So, sa madaling salita, ang anode, ito yung negative side of the battery. So, next one is cathode. So, ano nga ba yung cathode? It is the positive or oxidizing electrode that acquires electrons from the external circuit and is reduced during the electrochemical reaction. For example of it is manganese dioxide, carbon, lead dioxide, and then copper. So what does it mean? So for the simpler word lang po, ang cathode, it is the positive side of the battery. So let's tackle about the schematic diagram. Battery schematic diagram. So ano nga ba to? So as you can see sa figure, anode and cathode are being submerged by the electrolyte solution, and at the middle of it, it is a semi-permeable barrier. Ito yung nasa gitna. Ito, nasa gitna. So this barrier prevents the excess of the electron from the anode side to go directly in cathode side. So, etong barrier na to, tumutulong to para maiwasan na magpunta yung electron sa cathode ng directly. So, electrolyte and the anode forms a chemical reaction in a way that produces an excess of electrons, making the side of that anode a negative side. As we all know, producing many electrons, it will be keep on moving, transferring from one atom into random. At the same time, it will repel. So, maghahanap sila ng lugar kung saan mas may onting electron. Then, in cathode side naman, electrolyte and cathode forms a chemical reaction that produces a substance that is readily accepts electron, making the cathode side positive. So, in simpler word, anode produces electron while the cathode produces an electron acceptor. So, ibig sabihin, sa tulong ng electron flow, yung excess electron na pinoproduce ni anode ay magta-travel siya patungo kay cathode. At tuloy-tuloy na yung cycle na yun hanggang sa maubos yung ng battery. Let's tackle naman about sa battery construction. So, these are the part of the battery. Sa parang yellow part doon sa picture, ito yung tinatawag na metal cap. Then yung nasa gitna is carbon rod. or positive electron. Then yung zinc case naman niya, ito yung negative electron. Meron ding manganese oxide. Ito yung parang abo-abo. Ayan, yan nasa gilid. Then, meron naman yung moist phase of ammonium chloride. Ito yung electrolyte na ginagamit sa battery. Then, ito naman yung metal bottom. So, yun. Negative naman yun.
The battery and how it works. There are a couple of chemical reactions within the battery. At the anode, the electrode reacts with the electrolyte in a reaction that produces too many free electrons. As a result, these free electrons repel each other and try to go to a place with fewer electrons. Meanwhile, at the cathode, another chemical reaction occurs simultaneously that enable the electrode to accept electrons. In a battery, the only place to go is the cathode, but the separator keeps the electrons from going straight from the anode to the cathode within the battery. And when the circuit is closed, the electrons will be able to get to the cathode. So next, here are the chemical reactions in zinc-carbon batteries. Zinc-carbon batteries have different types, and different types of these batteries have different chemical reactions. And if you look at the presentation, shows the chemical reaction within these zinc-carbon batteries. For example, for one type is a battery where its anode is zinc. Cathode is manganese dioxide where carbon is added to increase conductivity, and the electrolyte used is ammonium chloride. The overall reaction in the cell is zinc plus 2 manganese and an oxygen with an atomic number of 2. Then progresses to zinc and oxygen was added in the reaction, plus the manganese was subtracted by 1 and an atomic number of 2 was added, and the oxygen element from 2 is added 1 more to become 3. Note, the exact mechanism for this is complicated, and there is still controversy over the exact mechanism. So there is no need to focus on this topic, and we'll move on to the next. So what you see is the representation for the working principle of a hydrogen fuel cell. Where the red circles are the hydrogen, the blues is the oxygen, and the greens are the proton, and the yellows are the electron. So the fuel cell stack also works like a battery. Now we'll show you how it goes. So during operation, hydrogen and oxygen are being supplied inside the anode side and the cathode side respectively. And what happens is when the diatomic molecules of hydrogen reacts with the catalyst made up of platinum, the hydrogen molecules get split into proton and electron particles, and these particles are heading to the cathode. But in the proton exchange membrane, only allows protons to pass through while blocking the electrons. Then the electrons that are blocked by the membrane is forced to take another path, which is the connecting wire that we see at the top that connects the anode and the cathode, where there consists a certain load. What happens next at the side of the cathode is that the protons that pass the proton exchange membrane and the electrons passing through where the load is located unites at the side of the cathode with the aid of the catalyst. The diatomic molecules of hydrogen is being combined with the diatomic molecules of oxygen, which produces the byproduct of water vapor. And as seen in the representation, the fuel cell is now working like a battery, providing the continuous flow of electrons, supplying direct current at certain load, as long as there is an ample supply of hydrogen and oxygen. You may further watch the illustration to further understand and appreciate how this fuel cell stack works. And what to remember in this representation is the byproduct by the hydrogen fuel cell, which is to be discussed in the succeeding slides.
So, sa mga nakaraang slides na pinakita, same lang din naman siya nung nilalaman. Kumbaga, pinakita lang to in a different type of view. So, makita nga din natin dito, yung hydrogen. So, yung hydrogen na pro-produce siya or napapump siya sa isang flow plate. Then, yung hydrogen naman, siya yung nag-pro-produce or kumbaga naglalabas siya ng anode. So, at the anode, a platinum catalyst that causes a chemical reaction splits hydrogen molecules into positive hydrogen ions and negatively charged ions. So, kumbaga, si anode, siya yung nag-split ng hydrogen positive ions and hydrogen negative ions. So, next natin dito is yung PEM or yung polymer electrolyte membrane. So, dito naman, yung kumbaga, pinapalabas niya lang or like pinapapass through niya lang is yung mga positively charged ions, forcing the negative electrons along an external circuit. So, next is yung water. So, ba't nga ba may water dito? So, oxygen combines with hydrogen molecules to make water which exists the cell. So, kumbaga, sabi nga rin, yung hydrogen yung magbibigay or hydrogen molecules, hahalo siya sa oxygen para mag-produce ng water. Next is yung cathodes. So, another catalyst at the cathode causes the negatively charged electrons and positively charged hydrogen ions to combine with oxygen to form water. So, kumbaga, yung cathode naman, yung magko-combine ng hydrogen ions at ng negatively charged electrons para mag-produce ng water. Next is yung oxygen. Yung outside oxygen is pumped into the cell through a flow plate. So, kumbaga, di ba sa kabilang side, yung red part dito, makikita natin doon nagpa-pump yung hydrogen. While yung blue part, doon naman nagpa-pump yung oxygen. So, last natin is yung nakalagay dito is yung electricity. The separated electrons are diverted along an external circuit creating an electric current. So, dito na nagsaseparate yung mga electrons para mag-convert siya sa isang electrical current. About the hydrogen fuel cell working principle. So, fuel cells work like batteries but they do not run down or need recharging. They produce electricity and heat as long as fuel is supplied. So, parang nangyari, yung fuel cell daw, nagparas din siyang battery na once na nag-produce din ng electricity and heat, yung fuel doon ay masusupply. A fuel cell consists of two electrodes, a negative electrode or the anode one, and a positive electrode called the cathode, sandwiched around an electrolyte. A fuel such as hydrogen is fed to the anode and air is fed to the cathode. In a hydrogen fuel cell, a catalyst at the anode separates hydrogen molecules into protons and electrons which take different paths to the cathode. The electrons go through an external circuit creating a flow of electricity. The protons migrate through the electrolyte to the cathode, where they unite with oxygen and the electrons to produce water and heat. So, para kung ang nangyari, yung mga catalyst sa fuel cell, yung yung anode, yung catalyst, yung na nasa loob ng anode, siya yung nagsaseparate ng hydrogen molecules sa, kumbaga, ipaseparate niya into protons and electrons. So, which take different paths to the cathode, sabi dito. Then, sabi rin dito, nakalagay sa huli, yung protons, nagmamigrate daw siya papunta sa electrolyte. So, from electrolyte, mapupunta naman siya sa cathode. So, dito naman nag-unite or nagsasama ng electrons and the oxygen molecules to produce water and heat. So, for this part, we have the schematic diagram. So, makikita natin sa bandang kaliwa, may nakita dalawang tangke dyan. Nakalagay is hydrogen tank and the oxygen tank. So,
Yung hydrogen tank, nagpo-produce siya or nagsusupply siya ng anode. While yung oxygen tank naman, nagsusupply siya ng cathode. So, para ma-achieve natin yung great amount of output within around 1,000 hydrogen fuel cell within the hydrogen power plant, during the operation, the product of the hydrogen fuel cell is water. So, kumbaga, nilalabas nun is hydrogen water kasi this is just a clean substance that doesn't cause any pollution. While the hydrogen fuel cell works like a battery and it produces a direct current. Kaya need dito ang inverter. So, kumbaga, ang purpose naman ng inverter ay i-convert niya yung pumapasok na direct current to alternate current. And also, may iwasan dito yung losses of very long conversion line kasi dapat nakakonect ito sa transformer. And then, yung transformer na nakakonect dun sa conversion line ay magsasend naman siya dito sa electric grid. So, kumbaga, yan yung process na nangyayari sa isang hydrogen fuel power plant. So, kumbaga, yung pinakita ng schematic design na to is just a concept design kung ano nga ba ang nangyayari throughout the hydrogen power plant. So, let's talk about why do we need to explore hydrogen power plant. So, let's read first one part of our PowerPoint. So, nakalagay dito, hydrogen is a very efficient fuel source capable of producing more energy per pound of fuel than gasoline. This means that an unequal-sized tank of hydrogen fuel would give a vehicle a greater range or more power than when filled with gasoline in an internal combustion engine. So, paano nga bang ibig sabihin nun? So, kung titignan, nowadays, meron tayong mga hydrogen-fueled cars and gasoline-fueled cars. So, ano nga ba yung pagkakaiba ng dalawa nun? So, if we compare both cars, yung volume na binibigay ng hydrogen-fueled cars and yung volume ng gasoline-fueled cars, mas mabilis pa rin ang nararating ng hydrogen-fueled cars kesa sa gasoline-fueled cars, which is according yon sa mga previous studies. So, kung babalikan natin yung mga nakaraang mga studies or like yung mga studies like kung babalikan natin yung mga nakaraang slides, diba, somewhere dito, fuel cells have much lower emissions than combustion engines. Hydrogen fuel cells emit only water, so there are no carbon dioxide emissions and no air pollutants that create smog and cause health problems at the point of operation. So bakit nga ba siya hindi nakakapagbigay siya ng no air pollutants, and also it doesn't create carbon dioxide emission. Bakit nga ba ganun yung nangyayari when it comes paggamit ay ang hydrogen power plant? So, kung babalikan natin yung mga previous slides natin, ang byproduct ng hydrogen fuel cell is yung water na kung titignan, less combustible siya, and at least kung ikukumpara sa gasoline fueled cell or yung mga gasoline engine cars, ganyan. Kasi, kumbaga, yung binibigay ng gasoline engine cars or mga gumagamit ng gasolina, more on combustible siya or like nag-e-emit siya na din ng mga carbon dioxide and more on pollution siya. While pag tinitignan naman natin yung hydrogen fueled cell or mga hydrogen ang gamit, it doesn't have air pollutants or kumbaga less combustible siya and at the same time nalalesen yung pollution na binibigay nito. So, dapat pala when it comes to having a pollutant. So, when it comes pala sa paggawa ng mga power plant, dapat meron siyang efficiency. Hindi din dapat siya nagpo-produce ng pollution and at the same time, quiet yung operation. Kasi kung titignan sa mga iba't ibang power plant dito sa Pilipinas or any power plants na meron tayo sa iba't ibang lugar, ay usually nasa malapit siya sa mga residential area. So, dapat efficient din yung binibigay nitong operation and at the same time, less pollution yung naibibigay din nito. So, it means, yung hydrogen power plant pala is maganda palang itayo kasi naibibigay niya yung kagandahan or like hindi siya nagpapalala ng ating mga environment kumbaga nagpapalala ng problema sa environment.
Why it hasn't gone mainstream? First is hydrogen production through methane. Based on this, about 95% of the hydrogen used today is produced by a process called stream reforming. When we say stream reforming, pag nag-extract ng hydrogen through methane, ito ay naglalabas ng greenhouse gases na nag-aambag sa global warming, which is dapat iwasan dahil sa global warming na maidudulot nito. Second, hydrogen production through water. Hydrogen production through water refers to a process called electrolysis. But the main reason kung bakit hindi ginagawa ang hydrogen production through water because mahal yung process na to. At kailangan din makaisip ng mga scientists to produce inexpensively. And next is cost. Why it hasn't gone mainstream because of cost. Dahil ang fuel cells ay masyadong mataas dahil sa paggamit ng platinum, one of the largest materials. So this is the main reason hydrogen power plant why it hasn't gone mainstream.
Hydrogen storage. Scientists are still struggling with the challenge of how to store hydrogen because it has such a low energy density. Hydrogen needs to be kept under strong compression to be a viable fuel source, necessitating strong tanks and heavy-duty fueling lines. So, data shows that there is still no major manufacturer who are willing to mass produce this type of tanks that are exclusively for hydrogen. And those companies who are just starting to build a small hydrogen power plant, still they are on a prototyping stage. That is why this is a major practical disadvantage. So the next one is hydrogen leak. So during this operation, during the extraction process, hydrogen leak is possible, and once it occurs, one major destruction that this leak would create is the depletion of ozone layer. And napag-aralan natin nung high school tayo, yung makapagpa-deplete ng ozone layer natin is yung CFC, which is chlorofluorocarbons. Pero mas malala yung epekto ng hydrogen sa ating ozone layer kaysa sa CFC. And ito yung dahilan kung bakit it hasn't gone mainstream. Next one is latest development. Long Range Energy Generation Project. Touted as a first of its kind power plant in the United States, the Long Range Energy Generation Project, a 485 megawatts facility being equipped to run on a mix of natural gas and carbon-free hydrogen, is nearing completion, so malapit palang matapos, at the site of a former aluminum smelter on the banks of the Ohio River. The facility first will burn a fuel blend that includes 5% of hydrogen in a General Electric Company H-class gas turbine. So 5% hydrogen lang yung contributor sa 485 megawatts. The plant is intended to transition to 100% green hydrogen over the next decade by relying increasingly on renewable energy to power electrolysis machines that split water into its hydrogen and oxygen elements. So yung hydrogen power plant is still on a exploration stage and parang trial stage ganun. Next latest development is the Siemens Energy, and ito recent lang to sinimulan. Yung cost nito is 170 million euros and situated ito sa remote part of French Guiana. These power plants offer very little capacity of fuel cell. The hydrogen fuel cell here is rated at 3 megawatts. Yung majority of this power plant output is the solar panel, which is 55 megawatts and 20 megawatts from its reserve capacity, which is the cell of batteries. And this project is still at its trial stage when it comes to using hydrogen energy. And yung mga researchers is syempre may mas marami pa silang dapat alamin tungkol dito sa hydrogen fuel and sa pagtatayo ng hydrogen power plant.